Hello students, welcome to RD Chemistry. Here I'll discuss the concept of Henry's law. Henry's law explains the effect of pressure on the solubility of the gases. According to Henry's law, partial pressure of the gas is directly proportional to mole fraction of the gas dissolved. Partial pressure of the gas directly proportional to mole fraction of the gas, mole fraction X, okay, dissolved in the liquid, any solvent. So partial pressure is equal to one constant Kh into the mole fraction of the gas. The partial pressure of the gas is equal to Kh Henry's constant into the mole fraction of the gas in the liquid. What is the partial pressure? Now when I take the solvent will have the vapors. These vapors can mix with the gas and the gas thus become the wet gas. But we want the partial pressure of the dry gas alone. Therefore, we are mentioning the pressure of the partial pressure of the gas is equal to Kh into the mole fraction gas dissolved in the liquid. Okay, fine. Now, this is the equation. So, if I plot the graph, Kh is a constant anyways. Suppose I want to try to plot along y-axis. Let it be the pressure. Maybe in terms of torr or in terms of atmosphere. Here let it be x, mole fraction of the gas. And you know that they are directly proportional to each other. It is like this is on the y-axis and mole fraction on the x-axis. Y is equal to mx. Equation of straight line passing through the origin, intercept C is 0, passes through the origin. So it is directly proportional to each other. And what is the slope? We can find out the slope. The m is slope here. The slope is nothing but the Kh value. Fine. What are the characteristics of the Kh now? Its unit is same as the pressure. Different gases have different values of Kh for the same solvent. Higher the value of Kh of the gas, lower will be its solubility. Solubility can be studied in terms of mole fraction X also. Suppose I have got P is equal to Kh into X. X is the mole fraction of the gas. Is also nothing but it's the solubility, how much dissolved, what is the mole fraction of the gas. So therefore, X is equal to pressure divided by Kh, keeping the pressure constant. If the Kh value goes on changes, X also changes. As the Kh value increases, the mole fraction gas decreases. As the Kh value increases, remember the solubility, mole fraction of the gas in the liquid decreases. Okay, fine. Now read this question. A gas is present with saturated water vapors over water liquid at a total pressure of 1.5 atmosphere. Vapor pressure of water at the same temperature is 0.5 atmosphere. What is the solubility of the gas in terms of moles in 10 moles of liquid water? Solubility will write in terms of first we calculate X value. The X value converted into number of moles N. Now the gas is saturated. That means they are given the total pressure. When I say total pressure, the pressure due to the wet gas. The pressure due to the wet gas. How do you get the wet gas? Wet gas is formed by pressure due to the dry gas. Pressure due to dry gas plus pressure of the water vapors. Okay, due to the pressure of the vapors of water. Total pressure they given, saturated the water vapor they given, it is the 1.5 is equal to pressure of the dry gas you have to find out. That is the partial pressure. Partial pressure of the dry gas plus partial pressure of the water vapors is equal to the total pressure plus pressure due to the water vapors are equal to, they are mentioned here, 0.5 atmosphere. So it is a 0.5. Therefore pressure of the dry gas alone is equal to 1.5 minus 0.5 is equal to 1 atmosphere, right? Now what do we have to calculate? We have to calculate the solubility, correct? So partial pressure is equal to Kh into the mole fraction X. Partial pressure of the gas is 1 atmosphere. What is Kh? Previously you have seen the graph. Slope is nothing but Kh value, right? Slope is nothing but Kh value, 5 into 10 power 3. And how do you calculate X? Mole fraction of the gas. Mole fraction of the any substance is equal to number of moles of the substance A divided by number of moles of substance A plus number of moles of the other substance B in the mixture. Now this is a gas. Solubility of the gas is very less. Now if I take Na plus Nb, Na stands for Latin for gas, and this for the say liquid water. Liquid water. What is more amount? And dissolved gas very less. I can neglect this Na term. So what I will be writing now? I will be writing number of moles of the gas divided by number of moles of the solvent, that is the water here. So therefore I will continue here. 1 is equal to 5 into 10 power 3 into number of moles of the gas, let it be N only, divided by number of moles of water they are mentioned in the question, 10 moles. Therefore finally when I substitute, N is equal to 10 divided by 5 into 10 power 3, and this will give me finally the answer. So this is equal to 1 divided by 5 into 10 power 2, correct? So this is equal to 5 divided 1 divided by, so 1 divided by 500. So this will finally give us 2 into 10 power minus 3. Okay, so this is the answer. This will be the mole fraction or the solubility expressed in terms of number of moles of the gas. Hope this is clear to you. So remember here student, this we meant for partial pressure of the gas is equal to Kh Henry's constant into mole fraction gas dissolved in the liquid. Partial pressure gas above the surface of the liquid, and this Xg stand for mole fraction of the same gas dissolved in the liquid. Okay, remember the slope here is equal to Kh value, Henry's constant. Okay, student, if you are watching for the first time, please do subscribe, like and share the videos. I'll be coming with some more videos, tricks and concepts. Please encourage me. Thank you for watching.